In this session, we will do two questions from JEST 2022. The first question is, the ratio of specific heat of electrons in a heated copper wire at two temperatures 200 degrees Celsius and 100 degrees Celsius is. We know that the electronic specific heat, it is directly proportional to temperature. C electronic is proportional to T. Therefore, C1 divided by C2 is equal to T1 divided by T2, which is equal to 200 plus 273. We have to convert temperature to Kelvin, divided by 100 plus 273 Kelvin, which is equal to 473 Kelvin divided by 373 Kelvin, which is equal to 1.27. Option A is the correct answer here. Now let's solve another question, which is also from JEST 2022. Here we are asked to find the ratio of minimum to maximum average energy of the particle. We are given a particle which can access three states, three energy levels. The first energy level has energy 1 eV, and second energy level has E2 is equal to 2 eV, and E3 is 6 electron volt. Now the average energy of the particle, it changes with the temperature, and we have to find this ratio, minimum to maximum average energy. So we have to find average energy minimum divided by average energy maximum. Now minimum average energy is obtained when we take low temperature limit, that is T tending to 0. When T tends to 0, entropy tends to 0, the particle predominantly occupies the ground state, and the average energy will be equal to ground state energy, which is 1 eV. This is because all the higher energy states are exponentially suppressed. You know the formula for average energy. This is equal to summation over n En Pn, where En is the energy of nth state, Pn is the probability of nth state, and Pn is given by e raised to minus beta En divided by Z. Z is the partition function. So all of the higher energy states will be exponentially suppressed. Here in this formula, beta is equal to 1 by kT. Beta is equal to 1 by kT. Now to get the maximum energy, maximum average energy, we can take the high temperature limit. That is when T is tending to infinity. Now when T tends to infinity, all states become equally probable. Equally probable. Now there are three states, therefore probability of any state, occupying any state, will be equal to 1 by 3. Probability of occupying first state is equal to 1 by 3 is equal to probability of occupying second state is equal to probability of occupying third state, because when T is tending to infinity, all states become equally probable. This is evident from the formula for probability also. Probability of occupying nth state is given by e raised to minus beta En divided by Z. Z is summation over R e raised to minus beta Er. In this case there are three states, so R runs from 1 to 3. Now beta is equal to 1 by kT, and T is tending to infinity. This implies beta is tending to 0. Therefore we have Pn is equal to e raised to minus 0 divided by e raised to minus 0 plus e raised to minus 0 plus e raised to minus 0. which is equal to 1 by 3. Therefore, average energy maximum is equal to E1 P1 plus E2 P2 plus E3 P3, which is equal to E1 is 1 EV, E2 is 2 EV, and E3 is 6 EV. 1 EV times P1 is 1 by 3 plus E2 is 2 EV times 1 by 3 plus E3 is 6 EV times P3 is also 1 by 3. Therefore, this is equal to 9 divided by 3 EV, which is equal to 3 EV. Therefore, the ratio of average energy minimum to that of average energy maximum is equal to, average energy minimum was 1 electron volt. 1 electron volt divided by 3 electron volt, which is equal to 1 by 3, which is equal to 0.333. Therefore, the correct answer here is 0.333.